Reversible reactions are reactions that proceed in both directions. Reversible reactions are indicated with a pair of arrows between the reactants and products pointing in opposite directions. That's sort of hard for me to get on this slide using this software, so I just have this double pointed arrow. So it means that A plus B will form AB, and it also means that AB will decompose to form A plus B, both the forward and reverse reaction are occurring. Reversible reactions engage in what is known as equilibrium. When a sufficient amount of AB builds up, the reversible reaction will occur to form A and B. Eventually, what will occur is the forward rate will equal the reverse rate, and the concentration of A, B, and AB won't change. The reaction is still going forward, but the reverse reaction is also going, so the concentrations stay the same. When this occurs, that's what's known as chemical equilibrium. It doesn't mean there are equal amounts of the reactants and the products. It just means the formation of the products is the same rate as the formation of the reactants. The reverse and forward reactions are going at the same rate, and so the concentrations of each are not changing. Not all chemical reactions engage in equilibrium. When that happens, the reactions are known as irreversible, and this tends to happen with very highly exothermic reactions such as combustion. Another example is when we break down our food. These chemical reactions are never reversed to reform the actual food. So some reactions are not reversible, and we tend to write those with an arrow just going in the direction towards the products. A plus B goes to AB. So let's look at sample problem 5.6 from your textbook. Determine whether the following reactions are most likely reversible or irreversible. And pause the video to do that. Well, the key to answering this question is looking at the arrows. If we look at A, 2N2O, double arrow, N2O4, because of this arrow here going back and forth, this is a reversible reaction. The product can form reactant, and reactant will form product. So this is reversible, and this can engage in chemical equilibrium. The next equation, HBr plus NaOH, this is actually an acid and base reaction. The arrow is only in one direction. This is not a reversible reaction. As soon as these products form, they do not form reactants. And burning gasoline in an automobile engine, this is actually irreversible. It will not, the products of burning will not go back to form the gasoline.